Okay, let's talk some more about probability. What if your outcomes are not all equally likely? Ah, then what do we do? Remember relative frequency from the previous chapter? The frequency of a category divided by the total number. Well, relative frequency is also a probability. And if your outcomes are not equally likely, then your probability is going to be a relative frequency. This is usually what we're working with when we're working with data sets. So here's an example, toothpaste packaging. Here are some really weird looking toothpaste packages. So suppose some market researchers were looking at which toothpaste package consumers preferred, and they gave them 5 designs to look at and asked them to pick their most preferred. So design 1 was preferred by 5 people, design 2 by 15 people, etc. And you can look at the numbers really quick and see that design 4 was the most preferred. Okay. Also, as it turns out, these add up to 100, which is very handy. And so we can calculate the relative frequency of this pretty easily. This adds up to 100. And so the relative frequency is, point 0.05, which is 5 divided by 100. And this one is 0.15, 15 divided by 100, 0.30, 0.40, and 0.10. So that should add to 1.00. Okay. And here it is in this very clean table. So an event is still a collection of sample points that meet some condition. So for example, we could say, what's the probability that you win the lottery with the numbers 2, 11, 14, 34, and 36? I'm actually not going to calculate that, but the chances are vanishingly small, which is why we don't play the lottery much. But we could say, for example, what is the probability that consumers prefer package 1 or 2? Okay, so then the event is, come back. The event, let's call that event A, is that they prefer package 1 or 2. All right. And the probability of event A here is the probability of preferring 1 plus the probability of preferring 2 is 0.05 plus 0.15 is 0.20. Okay. By the way, if we let B equal preferring package 4, the probability of B equals 0.40, which is greater than the probability of them preferring either 1 or 2, which is only 20%. Those are discrete distributions, but we may also have continuous distributions where we have numeric variables. So these are categorical, right? Design 1 is just labeled 1 for convenience, and 2 is number 2 for convenience, but these are actually categories. So this is categorical. What if we have a numerical variable? And it can be ratio, it can have an actual 0 point, and it could be discrete. So we say, how many times does your family sit down to dinner together each week? And that would be anywhere from 0, we don't do that at all in the week, to 7. That could be every night we do that. So since this is numeric, we could actually make a histogram and look at this, okay? And you can tell a couple of things from the histogram. First of all, the most frequent category is 7 days a week because it's got the highest frequency here. And the lowest categories are 0 and 1. It looks like those are exactly equal. But if I ask you for the probability of 0, it's around 10%, but it's a little bit harder to tell um, with the histogram. So it might be easier if we actually have a table. So here's the table. And we had 500 respondents in this study. You can see the frequency for both 0 and 1 was 11. So 11 people said that's how many times they did. 139 people said they sit down 7 times a week. So the relative frequency, this is in percent terms. In probability terms, we'd probably turn it back into a decimal. So, but this would be like, oop, there we go. So 11 divided by 500 equals 2.2%, or in decimal forms, 0.022. Okay. And 2.2% for 11 for the 1 time a week, all the way up to 27.8. Now, this is a place where cumulative frequency can also be useful because this is a numeric variable that has an order to it. So remember, for cumulative, we take the 1, first we start with the very first one, so the 2.2, we just bring it over. But then we add the next one, so we add the 2.2 and get 4.4, and then we add the 6 and get 10.4, etc. Okay. And now we can talk about the absolute probability of a certain thing. So we could say the probability of 4. Here we go. The probability is greater than 4, but the probability of 4 is equal to 0.08, or 8%. The probability of greater than 4, so this would be greater than 4. Notice that's a strictly greater, so it doesn't include 4. Okay, well, everything up to 4 is 25.6%. Here's where your complement comes in. Very handy. So the probability of x being less than or equal to 4 is 0.256. So the probability of it being greater than 4 is 1 minus 0.256 equals 0.744. I think that's right. That looks right. Okay. And for something like this, the probability of less than or equal to 2, it's super easy. We basically just read down the column, and we get to the 2 or less because that accumulates up to 2, and that one is equal to 10.4%, or 0.104. And that's it for